On the night of October 15th, the object known as 3I Atlas was struck by what appeared, at first, to be a solar-driven event, a coronal mass ejection of significant magnitude. But within hours, it became clear this wasn't a random encounter. Every major observatory monitoring the object reported something strange. The energy spike wasn't chaotic like a natural impact. It was structured. The object didn't destabilize or fragment. It stabilized, as if the entire event had been anticipated. Telemetry showed a rapid trajectory correction within a window of just 43 minutes, an adjustment so precise it effectively neutralized the CME's destabilizing force. That level of control isn't just rare, it's beyond any known comet behavior, and for many inside the deep space tracking community, it was the confirmation they'd quietly feared. 3I Atlas is behaving less like a celestial body and more like a mission. The shockwave data matched an emission pattern not unlike phased array transmissions. Ground stations in Chile, Australia and South Africa detected information-dense bursts across narrow frequency bands, bursts that began immediately after the impact window, not before. This timing matters. It suggests an energy harvesting event followed by deliberate communication. That's why, in the hours that followed, the world's largest space agencies shifted into silent coordination. NASA flight dynamics teams, ESA's tracking network, and multiple defense contractors all redirected assets toward the object. Public feeds remained quiet. Internal alerts did not. And it's not just the impact, it's the timing. In less than 4 weeks, 3I Atlas enters solar conjunction, an observational blackout that will last nearly 3 weeks. No telescopes, no ground-based tracking, no direct line of sight. The last time an object with this level of anomaly disappeared behind the sun, it emerged changed. What just happened is not a random space event. It's the opening move in something calculated, timed, and hidden behind the solar curtain. If the trajectory of 3I Atlas looks like a mission profile, its timing reads like a carefully choreographed operation. Every maneuver, every shift, every burst of activity seems to align not just with orbital mechanics, but with predictable solar and planetary windows. That level of synchronization isn't just difficult to achieve. It requires foreknowledge, precise models, and constant recalibration. The first major signal of this came at the end of August, when tracking teams noticed a subtle but deliberate adjustment. The timing coincided with a period of unusually low solar wind activity, a narrow gap between two moderate coronal mass ejections. It was a quiet pocket of space weather, exactly the kind of environment spacecraft engineers look for to execute delicate course corrections. 3I Atlas shifted then, and only then. Weeks later, as it entered its approach corridor toward Venus, another pattern emerged. Each of its inflection maneuvers occurred in proximity to orbital resonance windows, brief moments when gravitational relationships between planets minimize navigational energy. These are opportunities that mission planners spend months calculating for interplanetary probes. Yet here, a supposedly inert interstellar object was threading those windows effortlessly. Even more unsettling is the correlation with Earth-based observation cycles. Several timing events happen during new moon periods, when ground-based optical telescopes face reduced sky glow and more favourable tracking conditions. But 3I Atlas consistently shifted just before these observation peaks, as if deliberately minimising its detection signature during the moments when our sensors were at their most sensitive. Astrophysicists at multiple institutions ran probability models on this alignment pattern. The outcome was staggering. The chance of this series of maneuvers aligning with both planetary orbital dynamics and solar quiet periods by coincidence, less than 0.005%. The same probability analysts used to describe once-in-a-lifetime cosmological alignments. This timing precision wasn't just about evading noise or maximizing efficiency. It hinted at something deeper, an operational timeline. And that timeline points toward a single critical phase, the solar conjunction blackout in late November. Everything, from the August resonance maneuvers to the October CME harvesting, seems to converge toward this period. For decades, space agencies have treated solar conjunction as a vulnerability. Communication with probes drops to near zero as the sun blocks radio transmission paths. It's a time when even the most advanced missions are effectively blind. But if 3I Atlas is operating with intention, then that blackout isn't a weakness, it's cover. The pattern becomes even clearer when you overlay its signal emission schedule with the predicted conjunction arc. bursts appear to be stepping stones, synchronization pings, counting down toward that invisible window, each one more information-dense than the last, each one transmitted with perfect phase alignment to deep space monitoring intervals. Timing anomalies like these don't belong to passive rocks drifting through the void. They belong to systems that plan, adapt, and execute. And if this schedule is as deliberate as it appears, then the October event wasn't an accident. It was a trigger. But what exactly was triggered? The answer begins with what happened next, an event that changed everything. The collision that occurred on October 15th wasn't like anything seen in the history of interstellar object tracking. To the untrained eye, it looked like a massive solar-driven coronal mass ejection slamming into an object the size of a small mountain. Under normal conditions, such an impact would destabilize the body, induce chaotic spin, or strip volatile material from its surface. But when the CME struck 3I Atlas, the exact opposite happened. Within 90 seconds of the initial wavefront contact, the object stabilized. Deep space tracking arrays in Madrid and Canberra recorded a rapid vector correction, compensating for the CME's push in real time. The object didn't tumble, it held its orientation, a behavior unprecedented for any known cometary nucleus. At the same moment, magnetometer readings spiked, indicating a controlled electromagnetic response instead of natural deflection. This was not passive, it was reactive. Then came the shockwave anomaly. Instruments from the Solar Dynamics Observatory detected a perfectly symmetrical energy rebound, as if the CME had hit an engineered field rather than an inert surface. Normally, CME impacts create irregular scattering patterns, but this event produced a uniform dispersion cone, the kind generated when energy is redirected intentionally. But the true turning point was the signal that followed. Exactly 43 minutes after the impact, a timing window too precise to dismiss as coincidence, ground-based radio telescopes detected a tight band emission burst centered around 8.2 GHz. The signal carried distinct packet intervals, structured, repeating, information-dense. It wasn't broad noise like a flare echo, it was deliberate encoding. Spectral analysis revealed a complex modulation pattern, not language, not anything we could decode directly, but mathematically constrained, showing clear data compression. Within 10 minutes, the burst split into 3 frequency bands, each synchronized across hemispheric observatories. It was as if the object had harvested the CME's energy and then used it as a transmission power source. And then the emissions changed direction. Initial readings were omnidirectional, typical of scattering, but as the burst intensified, the beam narrowed, pointing first toward Jupiter's orbital path, then swinging back toward the inner solar system. That controlled beam steering is something we only see in phased array communications technology. It's how advanced satellites direct high-gain signals to specific receivers. To make matters stranger, no fragmentation followed the event, no debris field, no volatile dust plume. Infrared imaging expected to show a flare-up of sublimation, instead captured a clean electromagnetic envelope, expanding outward from the object. It was as though the CME hadn't damaged it at all, it had charged it. Inside multiple agencies, this was the moment quiet skepticism broke. Analysts at JPL, ESA, and Roscosmos independently reached the same unsettling conclusion. The event behaved more like a planned energy capture than a natural collision. In mission design terms, this is called opportunistic energy harvesting, leveraging solar storms to power operations, and the timing was perfect. Just weeks before the solar conjunction blackout, 3I Atlas had recharged. The maneuver placed it on an optimized approach arc with maximum energy reserves during a period when it would be invisible to most telescopes. The impact wasn't a disaster. It was a switch being flipped, and the evidence of what came next is even harder to explain away. The hours following the October impact exposed something no natural comet should be capable of: energy retention and active signal emission. Normally, when a CME collides with a small celestial body, the energy disperses chaotically. Its electromagnetic and thermal load simply radiates outward, leaving behind dust plumes, ion tails, and destabilized rotation. But 3I Atlas didn't radiate its energy away. It contained it. Telemetry from the Deep Space Network showed a sustained electromagnetic envelope surrounding the object for more than 6 consecutive hours after the CME event. This envelope wasn't just residual plasma turbulence. It was stable, with a uniform frequency peak at 8.2 GHz and harmonic subbands splitting evenly at fixed intervals. That harmonic spacing is the signature of controlled energy modulation, not random natural activity. Then came the heat signature problem. Infrared monitoring expected to see a spike followed by rapid cooling. Instead, 3i Atlas maintained a near-constant temperature profile, fluctuating less than 0.1 Kelvin across its surface. That's the thermal equivalent of a machine that absorbs energy and redistributes it internally, not a body being bombarded by the solar wind. Analysts compared the retention curve to advanced spacecraft power systems, and the resemblance was unnervingly close. For most comets, CME impacts produce long ion tails pointing away from the Sun, but in this case, the emission flow reversed. Plasma movement began to organize toward the Sun, pulling charged particles inward like a siphon. Observers dubbed it the reverse tail, an anti-tail effect that intensified over several hours. Plasma density readings suggested that the object wasn't just enduring the storm, it was feeding on it. And then came the signal bursts. At exactly 1800 hours UTC, radio telescopes in Chile, Spain and Western Australia received a coordinated 3-band emission sequence. Each burst was 1.7 seconds long, separated by precise 20-second intervals. These aren't random numbers. Those intervals match known solar oscillation harmonics, something a passive body wouldn't exploit, but a calibrated transmission system could. By now, ground stations were watching the signal behave in ways that defied inert object behavior. Its signal-to-noise ratio increased over time, meaning the transmission wasn't fading as energy dissipated. It was growing stronger. The most plausible explanation was also the most unsettling. The object had successfully harvested and stored CME energy, then converted it into targeted communication. High-resolution polarization data showed something else. The emissions carried structured polarization flips, a form of modulation often used in binary encoding. It didn't match terrestrial communication formats, but it wasn't random noise either. Some analysts began to treat it as signal architecture, a carrier for information of unknown content. Behind the scenes, several major agencies quietly shifted their protocols. Arrays normally assigned to deep space science were reassigned to track the object full-time. Signal intelligence units were brought in. What had begun as a curious comet had now been elevated to a strategic asset. But the most remarkable part is what happened when the energy output finally began to taper. Instead of collapsing back to a neutral state, the object's structural profile changed. Radar imaging revealed the emergence of high reflectivity nodes along its sunward face. To those monitoring, it looked less like a melting nucleus, and more like a machine rearranging itself for whatever was coming next. The energy harvest wasn't the end of the event, it was the foundation. And in the shadow of the coming solar blackout, that foundation began to grow. The transformation didn't happen in a single flash. It unfolded quietly, layer by layer, in the final 10 days before solar conjunction, when most of the world wasn't looking. While casual skywatchers thought 3i Atlas was simply slipping behind the sun, deep space tracking teams watched its radar, and reflectivity profiles begin to shift in a way that defied natural processes. The first indication came on October 23rd. The object's radar cross-section, previously stable, diffuse, and consistent with an irregular rocky icy body, suddenly spiked in reflectivity along its sunward hemisphere. Normally, this kind of spike would suggest fresh ice exposure from outgassing or fragmentation. But this was different. The reflectivity curve wasn't scattered. It was clean, with sharply defined edges and distinct nodes that repeated at precise intervals. Over the next 48 hours, these reflective zones expanded. The pattern showed near-perfect radial alignment, 3 dominant nodes arranged in a triangular configuration, and beneath them, secondary microstructures beginning to emerge in a lattice-like pattern. Every node faced the sun with astonishing precision. This wasn't chaos, this was architecture. By October 26th, the radar returns became even clearer. Angular structures with reflectivity coefficients matching metallic surfaces began dominating the sunward face. The angles weren't random. They clustered around 60 degrees and 120 degrees, forming hexagonal and triangular geometries. In spacecraft engineering, these are structurally optimal angles for modular arrays, especially when designed for energy harvesting or signal amplification. For natural formations, these configurations are statistically negligible, less than a 0.0001% chance of forming under normal thermal and mechanical stress. Infrared observations from orbiting instruments confirmed what radar hinted at. These zones weren't just reflecting light, they were absorbing and redistributing it. Instead of the temperature fluctuations expected from a rotating icy nucleus, 3I Atlas maintained a perfectly even thermal gradient across the newly formed structures, with fluctuations measuring below 0.05 Kelvin over a 24-hour period. That's the thermal behavior of a controlled surface, designed to manage energy input, not the chaotic thermal inertia of rock or ice. But it was the rate of change that alarmed the tracking teams. The growth was too fast to be geological or chemical. In less than 5 days, the object's sunward face changed more dramatically than any natural comet ever observed. Normally, significant restructuring would leave clouds of debris and ice plumes trailing behind, but the dust tail remained minimal, unnervingly clean. This wasn't erosion, it was construction. Multiple teams working independently overlaid the evolving radar profile with the timeline of CME energy absorption from Chapter 4. The match was exact. Energy spikes preceded structural changes by hours, as if 3I Atlas was converting harvested energy into physical infrastructure. Whatever these structures were, they appeared to grow in synchronized intervals, a rhythm, not a random process. And then came the orientation lock. High-resolution photometry showed the object was holding a fixed solar orientation. No tumbling, no chaotic drift. The sunward face remained perfectly aligned as the object moved along its trajectory, mirroring attitude control behaviors seen in active spacecraft. The precision of this orientation suggested constant stabilization inputs, far beyond what could occur through natural torque balancing. Engineers who examined the geometry began to draw unsettling parallels with phased array satellite systems and modular energy collectors. One comparison stood out repeatedly in internal memos. The formation resembled a segmented dish, the kind used to focus and amplify electromagnetic signals. When the last clean observation window closed, just 72 hours before conjunction, the structure had reached its most complex state yet. The main body of 3I Atlas was surrounded by a dense, honeycomb-like framework, each segment reflecting and absorbing solar radiation with clockwork consistency. Emissions in the 8.2 GHz band stabilized to a razor-thin frequency drift, as if the structure itself was now part of an integrated transmission system. Publicly, official channels referred to this as albedo variance and tail asymmetry caused by unusual outgassing. But privately, behind classified doors, the tone was very different. Internal assessments labelled the formation as a directional solar-facing array of unknown origin. This was the last image scientists had before the blackout window, a once simple interstellar object now wearing a metallic skin, radiating in clean, structured frequency bands, locked in perfect alignment with the sun. Then, as the world turned its telescopes toward the blinding solar disk, the object slipped from view, not destroyed, not silent, simply hidden, behind the one thing that blinds every eye on Earth. And for many inside those control rooms, that was the most unsettling moment of all. When 3I Atlas vanished behind the sun, most of the world stopped paying attention. But for those still watching the telemetry, something extraordinary began to happen. Normally, comets exposed to solar wind produce tails that flow away from the sun, long ionized streams pushed outward by radiation pressure. But this object broke the rule. Within just 36 hours of the blackout, instruments on the sunward side of the Earth, particularly those belonging to the Solar and Heliospheric Observatory, began picking up plasma structures flowing in the opposite direction. The data showed a sun-facing tail forming and intensifying, like a river of charged particles being pulled toward the object rather than pushed away. This isn't unheard of in cometary physics, but it is vanishingly rare. What makes 3I Atlas different isn't the presence of an anti-tail, it's the precision and control with which it emerged. Anti-tails in normal comets appear as diffuse temporary spikes, usually caused by perspective or dust alignment. This one was sharp, structured, and sustained for nearly 9 consecutive days, even as the object entered the deepest part of conjunction. Plasma density readings from the STEREO spacecraft showed the flow behaving more like directed intake than passive interaction. Instead of turbulent scattering, the flow exhibited steady-state laminar patterns, as if guided by some kind of electromagnetic control field. The magnetometer readings were even stranger, a subtle but consistent inversion in the local field orientation surrounding the object. Normally, CMEs leave magnetic turbulence behind. Here, 3i Atlas was shaping the turbulence, bending the plasma flow into order. Engineers who study field manipulation noticed something deeply unsettling. The signal fluctuations detected before conjunction matched the kind of phase-modulated signatures seen when radio beams are actively corrected to maintain coherence across unstable environments. In other words, whatever was happening out there wasn't random solar wind. It looked like field steering, a process that would require a deliberate adaptive system. For several days, the object became effectively invisible to Earth-based optical telescopes, but we could still listen. The 8.2 GHz emissions, previously intermittent, locked into a stable harmonic pulse. Every 23.4 seconds, the object emitted a narrowband burst, identical in shape, amplitude, and phase across multiple ground stations. These intervals coincided precisely with fluctuations in the plasma density of the anti-tail, suggesting the emissions and the plasma behavior were linked. When data from the Deep Space Network was stitched together, a pattern emerged. The anti-tail wasn't simply a physical anomaly, it was a component of the transmission system itself. Think of it less as a tail and more as a giant dynamic antenna, using the sun's own charged particle stream as a conductive medium. This concept is beyond anything humanity has achieved. Our most advanced probes struggle to maintain coherent communications near the solar wind, let alone harness it. Yet 3i Atlas was seemingly using the sun itself as part of its signaling infrastructure, bending radiation pressure, stabilizing particle flow, and transmitting data through a moving plasma lens. Another key anomaly, plasma polarization. Instruments detected alternating helicity in the anti-tail. Essentially, the direction of rotation of charged particles was flipping back and forth in rhythmic intervals. This is not something solar wind does on its own. It's something that can only happen through active modulation, like tuning a waveguide. When the blackout deepened, the anti-tail intensified further, forming what analysts described as a plasma funnel, a dense, symmetrical corridor pointing directly at the sun. No one could see the object visually anymore, but this plasma funnel acted like a lighthouse beam in reverse, showing exactly where it was and what it was doing. Behind closed doors, multiple agencies began treating the anti-tail not as an observational curiosity, but as a functional technology. Its structure mirrored theoretical concepts in electrodynamic propulsion and gravitational lensing communications, technologies far beyond current human capability. For naturalists, the last defense was coincidence, but the timing, the stability, and the link to transmission frequencies left fewer and fewer skeptics. The anti-tail was not just an anomaly, it was a signal amplifier, and the more stable it became, the clearer it was that something out there wasn't just enduring solar chaos, it was mastering it. By early November, as 3i Atlas reached the deepest point of solar conjunction, its orbital dynamics began revealing something that, for many scientists, was more unnerving than its signals or structures: its mass. For months, analysts had been calculating the object's trajectory using conventional gravitational modelling, the same tools used for comets, asteroids, and interstellar visitors. But the math started breaking down. The object wasn't moving the way a body of its estimated size should move. The expected deceleration from the CME impacts never happened. In fact, after absorbing a shockwave powerful enough to destabilize most small bodies, its velocity vector remained almost completely unchanged. At first, mission teams assumed this was an instrumentation issue, sensor noise, calculation errors, or plasma interference. But as the blackout window progressed, multiple independent tracking systems confirmed the same result. The object had effectively shrugged off a CME that should have altered its trajectory measurably. That kind of inertial stability implies one of two things. Either the object is far more massive than current estimates, or it is compensating for external forces with an active propulsion or field system. Neither explanation fits comfortably within the standard model of cometary behaviour. The original estimates put the object's mass somewhere in the 10 to the 11th to 10 to the 12th kilograms range, typical for large interstellar fragments, but the lack of measurable trajectory drift pushed those numbers into the 10 to the 14th kilogram range and higher. To put that in perspective, this is on the order of a small planetary moon, yet it's an object no larger than a few kilometers across. For an object that size to have such effective inertia, its density would need to exceed anything naturally observed in the solar system. If it truly has that kind of mass, the gravitational influence alone should have been detectable weeks ago. Nearby dust streams should have bent slightly. Minor perturbations in Venus's ephemeris might have been measurable, but none of that appeared. Instead, the object behaved as if massive when acted upon, and nearly massless when interacting gravitationally with other bodies. That paradox was the tipping point. It suggested a variable effective mass, something that either controls its gravitational signature or masks it. In theoretical propulsion research, this is sometimes referred to as gravity field manipulation, the ability to shape or modulate an object's interaction with surrounding gravitational fields, effectively controlling its inertial response. Humanity has only scratched the surface of this idea through fringe lab work and speculative models, yet 3i Atlas was behaving as if this capability was already being used. Telemetry from the Deep Space Network showed subtle but repeating micro-oscillations in its acceleration curve, synchronized with its 8.2 GHz transmissions. The amplitude of these oscillations was small, measured in millimeters per second squared, but they were too regular to be noise. They matched the kind of modulation you would expect from controlled inertial dampening or field adjustment. In plain language, something about the object was altering how mass affected it. Some theorists inside classified working groups drew a direct line between this behavior and the earlier plasma funnel phenomena. If the anti-tail is being used as part of an energy or field control system, it could also be involved in mass modulation. In certain advanced field models, manipulating local space-time curvature can make a body behave as if it weighs hundreds of times less relative to its surroundings, while maintaining full inertial stability internally. That would explain why the CME impacted nothing, why trajectory corrections appeared instantaneous, why the object's orbit remained unnaturally precise. The implications were enormous. A natural comet cannot generate the kind of internal energy required for gravity manipulation. The only entities known to produce sustained, structured field modulation are engineered systems, spacecraft, or something functionally equivalent. Even the most conservative analysts, those who, for months, had resisted labelling 3i Atlas as anything but a strange rock, began running numbers with a new assumption: artificial field control. And the results fit far better than the natural model. For the first time, internal reports from multiple agencies began to use the phrase non-passive gravitational behaviour. It was the technical way of saying, this thing is not just sitting there. It's controlling how the universe pushes and pulls on it. Mass doesn't lie, and in the case of 3i Atlas, the numbers pointed to something that behaves more like a ship than a comet. The moment the mass problem became undeniable, every deep space network on the planet began tuning its antennas more precisely to the 8.2 GHz band. By then, that frequency had become synonymous with 3i Atlas. It wasn't just a burst signal anymore, it was persistent, structured, and most importantly, evolving. When the emissions were first detected weeks earlier, they resembled broad spikes in the radio spectrum, simple, tight pulses that could have been dismissed as interference. But after the CME event and the emergence of the sun-facing structures, something changed. The bursts began to contain patterns, not human language, not a code anyone recognized, but mathematical structure that defied randomness. The first breakthrough came from signal processing teams in Australia and Japan, working independently. They applied the same statistical methods used to analyze pulses and fast radio bursts. Natural sources produce entropy curves that decay smoothly. Artificial or engineered transmissions produce periodic compression signatures, distinct statistical fingerprints that indicate information being intentionally packed into a signal. 3i Atlas emitted exactly that. High-efficiency compression burst with near-zero drift over time. Then came the modulation pattern. Over multiple observation windows, analysts found repeating phase shifts within the bursts, minuscule but precise. Each pulse carried polarization flips occurring at fixed intervals: 0.37 seconds, 0.41 seconds, 0.37 again. This wasn't a stable metronome, but it wasn't noise either, it was fractal. The deeper the resolution, the more nested structure they found, like the layers of an onion. By November 10th, spectral decomposition revealed what many had quietly suspected. The signals contained layered carriers, meaning multiple streams of data were being transmitted simultaneously, interlaced in a way similar to how modern multiplexing works in advanced telecommunications. A single burst from 3i Atlas contained the equivalent of hundreds of megabytes of structured information per second. For a passive natural body, that is impossible. Perhaps the most stunning discovery came from cross-hemisphere triangulation. By aligning data from arrays in Spain, Australia and Chile, analysts reconstructed directional beam steering inside the signal. Instead of radiating isotropically, like a star or a comet tail scattering radio noise, the transmissions were being aimed as if a high-gain dish were locked onto specific points in space. The beams swept through multiple positions in a repeating cycle: Venus, Mars, Jupiter, Earth, then back again. Each pointing lasted precisely 4 minutes and 12 seconds. This timing wasn't random. It matched the object's previously observed trajectory alignments. The emission cycle appeared to be tracking planetary positions, like a system conducting multiple line-of-sight communications with different locations simultaneously. Governments went silent. Agencies didn't. Behind the scenes, encrypted coordination channels lit up. Signal intelligence divisions, the same ones that monitor foreign communications, joined the astronomical teams. The shift in tone was subtle, but unmistakable. This was no longer treated as a space science anomaly. It was treated as a live signal. And then came the pattern recognition models. Using recursive fractal analysis, AI-assisted decoding teams discovered recurrent structures within the signal bursts, clusters of prime number intervals and geometric ratios corresponding to known physical constants, hydrogen hyperfine transition frequencies, pi, e, the golden ratio. These are not random numbers. They are mathematical universals, the kind any technologically capable intelligence might use to communicate across civilizations. The bursts weren't saying words, they were anchoring reference points, the cosmic equivalent of establishing a shared mathematical alphabet. But the most unsettling element was the timing of these transmissions. Each major modulation cycle coincided with key moments in its orbital blackout arc, when Earth couldn't observe it visually. As the object became invisible, the signal became most structured. The blackout wasn't just cover for movement, it was when the real transmission began. Signal reconstruction teams also noted a troubling asymmetry. The bursts were not all outbound. A subset of the transmissions were looped back, as if responding to something, an exchange we couldn't hear. Whether this means 3i Atlas was communicating with something else in the solar system, or bouncing its own signal off distant targets, remains unknown. But one thing is certain. These emissions cannot be explained by cometary physics. No ice, no dust, no outgassing can generate sustained multiplexed radio transmissions containing structured mathematical constants, beam steering, and stable phase coherence for weeks. This was no longer a question of whether it was transmitting, it was a question of who or what it was transmitting to. And the answer might be hidden in the one place we cannot look, behind the sun itself. In deep space operations, solar conjunction is universally regarded as a blind spot. When a probe passes behind the sun relative to Earth, it enters a communication and observation blackout lasting days or even weeks. Even our most advanced assets, probes orbiting Mars, telescopes at Lagrange points, fall silent during this window. The solar wind saturates the signal, the radio noise overwhelms everything and we lose line of sight. For decades, this has been a predictable weakness of human observation. For 3i Atlas, it appears to have been a strategic opportunity. The blackout officially began on November 21st. From that point forward, no ground-based telescope or optical tracking system could maintain visual contact. But unlike with ordinary celestial bodies, its signal didn't vanish. Instead, it became sharper. Over the next 48 hours, the signal-to-noise ratio in the 8.2 GHz band climbed steadily. Despite the increasingly dense solar interference, that alone was anomalous. By November 24th, something even more unusual happened. The object's emissions, previously steady and directed, began shifting beam positions at intervals of exactly 7 minutes and 8 seconds, each sweep aligning with one of several predicted planetary nodes: Venus, Mars, Jupiter, and a fixed point deep in interplanetary space, just shy of the asteroid belt. The beam steering precision during the period when the sun should have blinded the transmission was extraordinary. Engineers working with deep space communication arrays know how punishing solar conjunction can be. Even a slight plasma fluctuation can distort a signal beyond recovery. Yet 3I Atlas was transmitting with a clarity higher than pre-blackout levels. Its emissions cut through solar noise with surgical precision, as though the sun itself was being used as part of the system, not as an obstacle. It wasn't just the signal that evolved. Telemetry gaps from earlier tracking windows started filling in through indirect methods. Gravitational perturbation detectors positioned at L1 and L2 began registering subtle but synchronous oscillations in the solar plasma environment, faint echoes of what appeared to be coordinated activity. These oscillations matched the earlier beam's sweep intervals almost exactly. The implication was staggering. 3I Atlas wasn't just transmitting during conjunction, it was doing something active behind the solar curtain. The first major anomaly occurred at 2:14 UTC on November 26th. A sharp, coherent pulse swept through the plasma monitoring arrays, creating what engineers described as a clear line in a wall of static. It was as if a door had opened in the noise. The pulse lasted less than 2 seconds, but in that instant, multiple monitoring stations, including Canberra, Goldstone, and Villafranca, detected identical phase-locked signals. When decoded, those signals contained structured fractal intervals identical to previous bursts, but with a new signature, an inversion pattern, suggesting a two-way exchange. In other words, during a time when no signal should be readable at all, 3I Atlas was receiving and responding to something. Then, as the blackout deepened, radiation flux from the sun spiked briefly, a CME on November 28th. Normally, this would obliterate any hope of communication. Instead, analysts observed the opposite. The object's signal synchronized with the CME's leading edge, bending its emission frequency slightly upward in perfect lockstep. The effect was like watching a surfer ride a wave. 3I Atlas used the solar storm as a carrier, amplifying its signal rather than letting it be drowned out. This is something no human spacecraft has ever achieved. During solar storms, even hardened probes go silent. This object didn't just remain active, it became stronger. Meanwhile, Earth's observation grid fractured. Different agencies saw different things. Amateur networks received faint carrier bursts that official stations denied. A small number of classified uplinks went dark for several hours, leading to speculation that parts of the signal were not being shared publicly. Inside the agencies, analysts began quietly referring to the blackout not as a gap but as a deployment window, because whatever was happening behind the sun wasn't passive, it was planned. Telemetry suggests that by early December, just before it re-emerged, the object's signal burst structure doubled in complexity. The pulse rate increased, its beam sweep cycle shortened from 7 minutes to 4, and plasma echo patterns from the sun's far side suggested movement, not just along its projected orbit, but lateral adjustments as if something was maneuvering. For years, solar conjunction has been a natural blind spot. For 3I Atlas, it was a shield, a place to act unseen, and when the object finally emerged, it wasn't the same as the one that entered the shadow. When 3I Atlas re-emerged from behind the sun on December 4th, the shift in tone inside government and scientific institutions was immediate and unmistakable. Until that point, the story had been dominated by astronomers, orbital analysts, and a handful of signal intelligence experts. But once the first post-blackout data came in, the conversation quietly moved out of public science and into national security rooms. The object's orbital position was exactly where predictions placed it, but its physical and electromagnetic profile had changed dramatically. High-frequency radar showed a 19% increase in cross-sectional reflectivity compared to pre-blackout scans, a clear sign that the structures which began forming in late October had expanded or reconfigured. Emission strength in the 8.2 GHz band had more than doubled. Polarization patterns that were once intermittent were now fixed and stable, like a transmission platform operating at full capacity. But the most unsettling discovery came not from telescopes, but from defense-grade tracking networks. Several orbital monitoring systems normally used to detect classified satellite maneuvers picked up microvector shifts in the object's movement, tiny but deliberate lateral adjustments that were completely inconsistent with any natural gravitational dynamics. These maneuvers weren't just course corrections, they formed a pattern. Over a 72-hour window, the object performed 3 subtle trajectory refinements, each one timed precisely at intervals of 24 hours and 17 minutes, aligning with Earth's orbital geometry. On their own, these shifts might have been ignored, but when plotted on a celestial map, they formed a triangular vector network, a kind of station-keeping configuration, the kind used when a spacecraft stabilizes its position for operations, not just transit. Inside mission rooms in the US, Europe, China and Russia, there was little room left for denial. Comets don't perform timed maneuver sequences. Comets don't expand their structure mid-flight. Comets don't increase their transmission power during solar storms. This was something actively managing itself. The first interagency briefings happened within 48 hours of reappearance. NASA's Orbital Dynamics team, the ESA tracking network, and the US Department of Defense quietly entered into what one internal memo described as a unified situational framework. The language was bureaucratic, but its meaning was not. This object was now being treated as a strategic unknown. The classified alerts that followed were unusually coordinated. Key antennas, normally reserved for satellite surveillance, were retasked toward 3i Atlas. Several defense contractors received emergency requests for enhanced signal deconvolution. In Japan, the JAXA Deep Space Tracking Network increased monitoring intervals from twice daily to round-the-clock coverage. The National Reconnaissance Office in the US issued an internal advisory referring to the object as a non-cooperative emitter, a term typically reserved for unidentified foreign assets in orbit. But the most telling sign came from the quiet mobilization of resources. Air Force Space Command repositioned assets at key listening posts. An unusually large amount of bandwidth was redirected to deep space communications relays. Civilian astronomers noticed a sharp increase in data silence. Observatories that had previously shared open tracking logs began withholding updates. Information flow narrowed overnight. This wasn't just about science anymore. It had crossed into strategic risk assessment. Several leaked internal notes, circulated among researchers who had worked on the object before the blackout, hinted at what agencies were most concerned about. The transmission behavior was now stable enough to be directed intentionally toward Earth. The mass and maneuvering gave it the potential to maintain stationary positions relative to planetary vectors. Its energy output was anomalously high, possibly tapping the sun's plasma stream in real time. No one was calling it an alien craft in the official memos, but the wording, non-passive behavior, structured emission, active stabilization, strategic unpredictability, all pointed in the same direction. Whatever this thing was, it was now being treated as an actor, not a rock. The world's scientific community, meanwhile, began to fracture. In public, major agencies remained cautious, speaking of anomalous behavior under review. In private, research teams were being sidelined or absorbed into classified channels. Independent astronomers were met with delays or denials when trying to access newly restricted telemetry streams. The moment 3i Atlas reappeared from the blackout, the debate shifted from what is it to who controls the response. And as the political silence thickened, scientists who had spent months studying the object from open platforms suddenly found themselves on the outside, watching as the story they helped uncover slipped into the shadows of state control. In the weeks following 3i Atlas's reappearance, the scientific community split cleanly in two. On one side stood the public-facing astronomers, academics, and institutions trying to maintain a fragile sense of normalcy, framing the object as a highly unusual but natural interstellar visitor. On the other side were the research teams now working behind closed doors, operating under non-disclosure agreements and classified communication channels. It was a fracture that widened fast. The first signs of the split came on December the 6th, just 2 days after the object emerged from conjunction. Several prominent observatories, including those in Chile, Hawaii, and Spain, stopped publishing raw tracking data to the global research feeds. Public databases that once showed minute-by-minute positional logs of 3i Atlas suddenly froze at timestamps just before the blackout. Requests for updated data were met with instrument calibration explanations that many in the field recognized as a cover. But the real break came when papers began appearing in rapid succession, each offering conflicting narratives. One camp, largely tied to major agencies, published heavily qualified analyses describing the object as a thermally anomalous cometary body, exhibiting unusual plasma interaction effects. Their language was technical but intentionally vague, with key data missing from methodology sections. The other camp, smaller, decentralized and increasingly independent, refused to accept the sanitized version. These were the amateur astronomers, university teams outside major funding networks, and private deep space signal groups who had been tracking 3I Atlas since before the October impact. They noticed gaps in the public record, orbital data that no longer matched the object's observed position, power readings that didn't fit known comet behaviour, and signal characteristics that were simply too precise to be explained away. As these independent teams released their findings, the language shifted from careful academic tone to direct accusations. Some accused agencies of data suppression, others of outright disinformation. Internal emails from several research networks later leaked revealed growing frustration. "We've been studying this object for months," one astrophysicist wrote, "and now it's like we're being told to unsee what we saw." The flashpoint came with a series of signal deconvolution studies, released anonymously through encrypted academic channels. These papers demonstrated, with clear mathematical rigour, that the emissions detected during the blackout weren't random noise but intentionally structured multiplex transmissions. The authors overlaid the data with previously published public readings and showed deliberate omissions in official datasets. Within 72 hours, the papers were pulled offline, but copies had already spread. Meanwhile, academic conferences became battlegrounds. At one particularly charged symposium in Geneva, a senior ESA scientist argued that there is no conclusive evidence of non-natural behaviour, only to be met with live-streamed signal telemetry from independent ground stations, showing the real-time emission pattern, sharper and more structured than ever. The room fell silent. Funding pressure intensified. University research groups dependent on national grants quietly received warnings. Do not make definitive statements without agency review. In some cases, access to critical telescope time was suspended overnight. Teams that continued publishing were forced to rely on amateur networks, backyard telescopes, private receivers, and bootstrapped signal processing arrays. Ironically, this fragmentation accelerated discovery. Freed from bureaucratic oversight, several independent clusters began cross-verifying their findings in real time, building a clearer picture than what was available through official channels. What they saw was unmistakable. The emissions were increasing in strength and complexity week by week. The orbital trajectory remained unnaturally stable, with maneuver signatures repeating at exact intervals. The thermal behaviour of the object defied any known physical model of cometary activity. As evidence mounted, the language within the independent community hardened. Words like mission profile, field control austere, and repeater array began replacing object or body. This shift wasn't just linguistic, it reflected a paradigm break. For decades, the scientific community has lived by the principle of shared observation, but 3I Atlas turned that principle inside out. Data was being classified, signals were being filtered, access was being revoked, and a story that began with open science was now divided by silence, secrecy, and competing narratives. A few senior scientists tried to bridge the divide. They urged caution, cooperation, restraint. But their calls were drowned out by the accelerating drumbeat of leaks, public suspicion, and a growing sense that something extraordinary was being managed, not just studied. And while the scientific world fractured, something else was happening outside academia entirely. The rise of a parallel network of civilian observers determined to expose everything the official channels wouldn't. Long before governments sealed off the data streams, the first eyes to truly follow 3I Atlas had never belonged to any agency. They belonged to amateur astronomers, a loosely knit global web of hobbyists, private researchers, and independent radio operators who'd been watching the sky long before October's impact. When the scientific world fractured, this network didn't just keep working, it expanded. Unlike institutional telescopes, these observers didn't rely on permission. They had no committees, no funding chains to be cut off, no legal pressure points to quietly squeeze. Their telescopes sat on rooftops, desert flats, mountain plateaus. Many of their antennas were home-built, cheap and inefficient compared to national arrays, but what they lacked in power, they made up for with numbers and freedom. The pivot began in late November, during the blackout window. While agencies issued their carefully worded statements about temporary observation gaps, thousands of amateur radio astronomers were still recording the 8.2 GHz bursts in real time. A small collective in Argentina noticed something first. The beam steering pattern was repeating with exacting precision every 4 minutes and 12 seconds, the same pattern noted in pre-blackout government leaks. Within hours, observers in Italy, Australia and South Korea confirmed it. No single amateur station could have resolved the entire signal, but collectively their network stitched it together. Dozens of stations synchronized their receivers using atomic time servers. They shared raw data through encrypted peer-to-peer channels outside the reach of traditional academic oversight. Within days, they had built their own real-time global signal net, something governments had underestimated they could do. When 3i Atlas re-emerged on December 4th, these amateur stations were already positioned. They recorded every burst. Unlike official releases, which had already begun emitting frequency spikes and phase anomalies, the amateur logs preserved the full signal stream, and what they saw was staggering. The signal strength had more than doubled, just as classified reports later confirmed through leaks. But what amateurs documented in detail was something agencies had never acknowledged: a low-frequency subcarrier embedded beneath the main 8.2 GHz burst. This subcarrier, almost invisible in standard analysis, carried a separate pattern of slow rhythmic modulations, something that looked more like telemetry than broadcast. Then came the directional sweep. Using simple but coordinated parabolic antennas, a coalition of observers in Japan, Germany and Chile tracked the beam vectoring across the sky. Every few minutes it snapped from one planetary alignment to another: Venus, Mars, Jupiter, then back. The sweeps were so precise they could be time-stamped to the second. For amateur observers, this was their moment of clarity. This object wasn't just emitting, it was targeting. What made their work powerful wasn't their equipment, but their openness. Unlike agencies, they published everything: raw signal logs, positional data, frequency waterfalls, beam vector diagrams. Within hours, data was mirrored across hundreds of servers. Even if someone tried to silence them, the evidence was already replicated worldwide. The movement began to coalesce around December 9th. Thousands of small telescopes and antenna operators formed what they called the Open Sky Network, an informal, decentralized alliance with one simple principle: if they hide it, we show it. Overnight, their live streams and dashboards began reaching millions of viewers online. For the first time since October, ordinary people could watch the signal in real time, unfiltered, and what they saw left little room for ambiguity. The signal wasn't decaying, it was intensifying. The sweep intervals were shortening. The subcarrier's amplitude was rising. Something behind that object was scaling its activity upward, not winding it down. By mid-December, amateurs had reverse-engineered partial structures within the modulation, detecting repeating prime sequences, orbital constants, and what appeared to be positional markers. It wasn't a language, but it was organized, and that alone changed the tone of the conversation worldwide. Public trust in agency statements eroded rapidly. When official press releases described the emissions as plasma-scattering artifacts, they were immediately confronted by live visualizations from amateur feeds showing structured coherence. Thousands of people were witnessing something governments were actively downplaying. This wasn't just about science anymore, it was about control of the narrative. A quiet but very real information war had begun between centralized institutions and a scattered but relentless network of civilian observers. And unlike the official world, the amateurs didn't have to agree on what it was. All they had to do was show it. And as they streamed every pulse to the world, their audiences grew. So did the sense that something extraordinary was unfolding. Not above us, but behind the sun, in a place no one could look directly. The arrival window, late November to mid-December, had been marked on agency calendars for months. It was the period most orbital models had flagged as critical. If 3i Atlas were to perform any decisive maneuver, deploy probes, or adjust its trajectory in a way that revealed intent, this was when it would happen. But nothing happened. At least not in the way anyone expected. No dramatic deceleration, no visible approach, no fragmentation trails. The night skies remained deceptively ordinary. There were no emergency press briefings, no stunning telescope images, and yet, deep in the telemetry archives, something very deliberate unfolded in silence. When 3i Atlas emerged from behind the sun, its trajectory was exactly where predictive models had placed it, down to the kilometre. But the object itself was not the same. Its reflectivity profile, emission strength and field modulation characteristics had all changed. Yet it had done so without any visible sign of transition. If something significant occurred, it happened while the world was blind. On December 14th, just 10 days after Reemergence, multiple orbital tracking stations noticed a subtle but undeniable increase in effective cross-sectional area. The object's radar signature had widened, but its visible dimensions had not. This discrepancy was impossible to reconcile with standard models. It was as if something had unfolded, expanded invisibly, without producing any measurable debris or light signature. Then came the echo anomalies. Ground stations in Japan and Germany reported faint periodic secondary reflections from near the object's position. These echoes appeared and vanished with extreme regularity, every 6 minutes, 18 seconds. They were too faint to be independent objects, yet too structured to be atmospheric interference. This pattern suggested coherent formations, possibly smaller units maneuvering in close proximity to the main body. Official explanations labelled them instrumental noise. Amateur signal networks disagreed. Their independent readings confirmed the same timed pulses occurring at identical intervals across hemispheres. It wasn't noise, it was a pattern, and then there was the emission shift. On December 16th, the 8.2 GHz band that had defined the object's transmission profile since October underwent a sudden band split. Instead of one coherent frequency, it began broadcasting on 5 parallel bands: 8.2, to 8.4, 8.6, 8.9, and 9.1 GHz. Each carried the same fractal encoding structure, but with slightly staggered timing. Analysts likened it to a burst array, a technique used in advanced communications to increase data throughput and resilience against interference. And all of this happened without any observable event. No heat bloom, no visible expansion, no deceleration spike, no anomalous light curve. The object simply slipped out of blackout stronger than before, as if it had spent the solar conjunction quietly building, deploying, or linking with something unseen. Inside multiple agencies, the tone of internal reporting shifted once again. Early October had been observation. Early November had been monitoring. By mid-December, the language was post-blackout operational phase. Analysts began to speak of silent vector insertions and invisible deployments, language used when something happens but can't be seen directly. For civilian observers, the absence of spectacle only amplified suspicion. The open sky network streams filled with speculation. People noticed the shortened sweep intervals of the signal beams, the synchronized echo pulses, and the structured multiband emissions. If something was moving near 3i Atlas now, it wasn't broadcasting its presence through light or heat. It was broadcasting through pattern, and pattern, unlike light, cannot be hidden by the sun. By December 18th, triangulated data strongly suggested that at least 2 additional signal sources were moving in lockstep with the main object. They were too weak to image directly, but their signals aligned precisely with the timing anomalies observed since the blackout. Some analysts called them children, others nodes. Official channels had no comment at all. The most remarkable part wasn't what was seen, it was what wasn't. No visible arrival, no landing, no descent signatures. Just silence. A silence that felt engineered, as if the entire blackout event had been designed to mask a deployment that we'd only detect after it was already complete. And by the time anyone realised this, 3i Atlas had already settled into its new post-blackout configuration, radiating stronger, cleaner signals, surrounded by faint structured echoes, as if a hidden phase of the mission had concluded while no one was looking. The arrival window didn't bring a spectacle, it brought a reality. Something had changed in the dark. When 3i Atlas finally came fully back into view in the 3rd week of December, the first high-resolution composite images sent through reconstruction filters left analysts silent. The object that now occupied that orbital corridor was not the same body that had entered conjunction a month earlier. At first glance, it retained its elongated shape, roughly 6 kilometers end to end, but the surface geometry had transformed. What once appeared as irregular ridges and pits now exhibited smooth linear contours, like panels fused together. The albedo variation across the object's sunward side had decreased dramatically, replaced by consistent reflectivity bands running parallel to its rotation axis. Those bands were evenly spaced, as though manufactured. Thermal imaging showed perfect heat distribution across those bands, uniform within 1/10 of a degree. Natural materials, ice, rock, metallic dust, never maintained such thermal equilibrium, especially after exposure to solar radiation. This was the thermal signature of a surface actively managing energy flow, redistributing heat like a machine regulating its internal systems. The radar cross-section confirmed what the visuals hinted at. Where radar once bounced erratically off a rough nucleus, it now reflected in clean planar echoes, as though hitting flat surfaces. Phase-coherent reflections formed symmetrical interference patterns consistent with arrayed geometry, panels, facets, or modules. The formation was too ordered to be geological. And then the emissions. The 8.2 GHz transmissions had now stabilized into 5 synchronized channels that cycled continuously through complex harmonic modulations. The intervals matched those detected during the blackout: 8.2 to 8.4, 8.6, 8.9, and 9.1 GHz. But now, all 5 bands carried interlinked phase codes, like nodes in a distributed system talking to one another. What had begun as simple bursts months earlier had become a coherent multi-channel network, perfectly phase-locked and synchronized down to microseconds. When plotted on a frequency-time map, the transmissions revealed something eerie. The bursts weren't random. They mapped into repeating geometric frames, specifically hexagonal and triangular grids. The same geometry that radar had shown forming on its surface weeks earlier was now reflected in its communication structure. The object was transmitting in the same shapes it had built into itself. That's not a coincidence. That's system integrity, a machine broadcasting in its own design language. But the most unnerving detail emerged from the motion data. The object was no longer tumbling through its orbit like most comets. It was rotating with deliberate periodicity, a perfect stabilization cycle repeating every 14 hours and 33 minutes. Each cycle aligned its primary face toward the sun, then toward deep space, maintaining orientation like a survey platform scanning in 2 directions. Independent observatories confirmed another shock. The smaller echo nodes detected during the arrival window were still there, 2 of them, maintaining identical orbital velocities and spacing, roughly 27 kilometers apart from the main body. Their signal bands were faint but synchronized, their frequencies locked in perfect harmony with 3i Atlas. Together they formed a triangular array, a configuration optimized for spatial triangulation and interferometric mapping. It was as if the object had deployed its own sensor network while hidden behind the sun. To mission planners familiar with orbital mechanics, the implications were staggering. The arrangement allowed 3i Atlas to perform real-time 3-dimensional mapping of both planetary magnetic fields and solar wind vectors, capabilities far beyond human probe networks. This wasn't a random scattering of debris, it was a functioning reconnaissance geometry. The global reaction was predictable and divided. Official agencies maintained silence, releasing vague statements about surface evolution and solar sculpting effects. Meanwhile, the Open Sky Network's civilian analysts were publishing raw data showing precisely timed signal synchronization between all 3 bodies. The coordination was undeniable. Even the frequency drift patterns carried meaning. Analysts noted minute variations, barely perceptible, that oscillated in correlation with Earth's position relative to the object. The emissions subtly mirrored Earth's orbital phase, as if 3i Atlas were now including our planet as part of its mapping grid. For the first time, a growing number of independent scientists began using a term that had previously belonged to fringe forums: adaptive intelligence. Not consciousness in the human sense, but the unmistakable capacity for goal-directed modification. An entity capable of learning, responding, evolving. By December 28th, with the object now clear of solar interference, one last anomaly sealed the conclusion. During a 48-hour observation window, 3i Atlas emitted a low-frequency pulse that propagated through multiple bands simultaneously, an encoded burst that repeated exactly 3 times, then stopped. Afterward, all 5 channels fell silent for nearly 20 hours. When they resumed, the modulation baseline had changed completely. The pattern resembled handshake protocols, as if a major data exchange had just occurred and the system had entered a new operational phase. Whatever happened behind the sun had not been passive observation. It had been construction, coordination, and calibration. 3i Atlas had emerged as something integrated, self-stabilized, and actively engaged in structured transmissions across the solar system. The world still hadn't seen it move dramatically, hadn't watched it erupt, hadn't witnessed proof of arrival. But in silence, in mathematical precision, it had done something far more significant. It had rewritten its own configuration, and possibly its purpose, while hidden in the one place where no one could look. The blackout hadn't ended, it had simply changed form. By the closing days of December, the debate surrounding 3i Atlas had shifted from what happened to what we are dealing with. For months, cautious language dominated every discussion: anomalous trajectory, unusual field behaviour, structured emissions. But as the object's post-blackout configuration revealed itself with increasingly precise data, even the most conservative analysts had to confront what was becoming impossible to ignore. The behaviour fits intent. The evidence had stacked up layer by layer, a near-perfect interplanetary trajectory, statistically impossible without guidance. Energy harvesting from a CME without destabilization, symmetrical structural growth during solar conjunction, plasma field control and anti-tail engineering, variable inertial response inconsistent with any natural body, multiband, high-efficiency transmissions using fractal and geometric encoding, and, most damning of all, the deployment of coordinated node structures operating as part of a deliberate array. This wasn't the footprint of a drifting object. It was the signature of a system. The intelligence debate didn't explode publicly. It spread through quiet, encrypted threads between astrophysicists, orbital dynamicists, and deep space communication experts. Words were chosen carefully. No one wanted to be the first to say what everyone was already circling around. Terms like self-organizing probe, non-passive system, and autonomous platform replaced the word craft. The idea wasn't that someone was piloting it in real time, but rather that something built it with purpose. 3 primary hypotheses emerged inside these closed networks. The first was the passive beacon hypothesis, the notion that 3i Atlas is not reacting to Earth at all, but simply running a pre-programmed survey routine. According to this model, it's an artifact, an ancient autonomous machine seeded by an unknown civilization, mapping stellar systems as it drifts through them. The repeating geometric transmission patterns, in this view, are not directed messages, but calibration and telemetry protocols, like a robotic probe maintaining synchronization with its own internal architecture. The second, far more unsettling theory was the active observer hypothesis. In this scenario, 3i Atlas is not only scanning but responding, modulating its transmissions in real time based on planetary alignments, solar conditions, and possibly even Earth's behaviour. The subtle signal shifts aligned with Earth's orbital position after the blackout gave this theory weight. Proponents argue that the object adjusted its network once Earth came back into its clear line of sight, integrating us into its mapping lattice. It's not necessarily hostile, but it's watching. And then there's the third hypothesis, whispered more than written. The relay hypothesis. This theory suggests that 3i Atlas may not be the originator of the signals at all. Instead, it's acting as a node in a much larger network, a relay or transceiver, part of a communication system that existed long before we ever noticed it. Its alignment behavior, beam steering, and blackout phase handshake bursts fit the profile of a system awaiting or relaying data, possibly to something outside the solar system. Within government circles, this third hypothesis quietly gained traction. Classified intelligence bulletins shifted language from object of interest to strategic persistent emitter. It wasn't just an anomaly anymore, it was a presence. Publicly, nothing was said. Official statements grew shorter, drier, vaguer. But behind the curtain, surveillance expanded. Deep space arrays were retuned, solar monitoring satellites were repurposed, and at least one orbital asset normally dedicated to geostationary surveillance was retasked to track the object around the clock. Meanwhile, independent observers pushed forward without waiting for permission. The Open Sky network continued releasing raw signal data, and by the end of December they had identified stable modulation patterns in the handshake bursts. The intervals contained prime number sequences, logarithmic spirals, and resonances matching Earth's orbital harmonics. If this is a language, it's one written in mathematics, the only universal tongue. More alarming still were the node echoes. Over multiple nights, at least 5 separate amateur networks detected additional faint sources blinking in and out of phase lock with 3i Atlas's main transmission. The echoes didn't correspond to known satellites, asteroids, or background noise. Whether these were actual physical companions, reflections from the plasma funnel, or other network components, no one could yet say. But the pattern was deliberate and growing. Inside academic and intelligence circles alike, one realization began to take root. This object was no longer just an astronomical curiosity. It was an operating system running on scales humanity was only beginning to detect. And then came the quiet shift in tone that always precedes historic change. Experts stopped asking, "Is this intelligent?" They began asking, "What's it doing? And how long has it been doing it?" Because the most disturbing possibility isn't that 3i Atlas just arrived. It's that it may have been waiting behind the noise of the stars, waiting for alignment, waiting for someone to finally notice the signal. And when humanity finally did, it was already too late to call it silence. For centuries, silence has been the backdrop of our search for the unknown. Astronomers scanned the skies listening for a signal that never came, convinced that if someone, or something, was out there, the universe would whisper back. But what if the silence wasn't a lack of presence? What if it was the result of something designed to remain unheard until it decided otherwise? That's the weight of what 3i Atlas represents, an object that entered our solar system on a path too precise to be chance, that absorbed a solar storm not as a victim but as an engine, that grew geometric, modular structures while hidden behind the sun, that emerged transmitting multiband, mathematically anchored signals, that positioned itself with quiet precision, surrounding itself with a lattice of faint synchronized nodes. Through all of this, no declaration was made. No beacon lit the night sky. No spectacle announced its arrival. Instead, everything unfolded with the deliberate subtlety of something that never needed to reveal itself. Something that had already accounted for our blind spots, our limitations, and our assumptions. Agencies called it non-passive behavior. Observers called it a machine. And the world, whether it wanted to or not, started to see the universe differently. Because for the first time, the silence we've lived with for so long wasn't empty. It was occupied. Some believe 3i Atlas is simply observing, a silent witness, scanning a young, noisy species still learning how to look beyond its own star. Others whisper of something older, quieter, more deliberate, a system that has moved through many star systems, never speaking, never touching, just recording, watching, waiting. And maybe that's why no clear message came, because perhaps it was never meant for us to hear it first. As the year closes, the object continues its trajectory, emitting in 5 synchronized channels, rotating with clockwork precision, maintaining a triangular node array like a cold mathematical heartbeat in the dark. Governments remain quiet. Public feeds speculate. Amateurs keep listening. And above it all, 3i Atlas says nothing. Just a rhythm. Just a pattern. Just the soft pulse of something older than our fear and quieter than our curiosity. The silence isn't over. It's become part of the story. And somewhere, hidden behind its transmissions, is the single most unsettling possibility of all. That we were never the first to look up.